That is module 3, ma'am, or module 2 only?
Module 3. ಇಲ್ಲ
Oh.
3ನೇ. ಯಾಕೆ ಮೇ ಬಿ ಅವರು ಡುವೆಲ್ ಸಿಂಪ್ಲೆಕ್ಸ್ 2 ಫೇಸ್ ಬಿಟ್ಟಿದಾರಂತ ಅನ್ಸುತ್ತೆ. ಐ ಡೋಂಟ್ ನೋ. ಕೇಳ್ಬೇಕು ಅವ್ರನ್ನ.
No, but A section was along with us when we were
Yes,
doing
yes,
the
yes.
simplex method, ma'am.
ಅವ್ರೇನ್ ಮಾಡಿದ್ರು ಅಂದ್ರೆ ಲಾಸ್ಟ್ ವೀಕ್ ಬಿಗ್ ಎಮ್ ಮುಗಿಸಿದ್ರು, ಡಿಜೆನರಸಿ ಮುಗಿಸಿದ್ರು. ದಿಸ್ ವೀಕ್ ವಾಟ್ ಶಿ ಹಸ್ ಡನ್ ಯೆಸ್ಟರ್ಡೇ ಐ ಥಿಂಕ್. ಹೆಂಗ್ ಗೊತ್ತಾ ಇದು, ಯಾರು ಹಿಂಗೆ ಲೈಕ್ ದೇ ಡೋಂಟ್ ಸಾಲ್ವ್ ದಿ ಎಂಟೈರ್ ಪ್ರಾಬ್ಲಮ್. ದಿಲ್ ಗೋ ಆನ್ ಗಿವಿಂಗ್ ಯು ದಿ ಡಿಫ್ರೆನ್ಸಸ್. ಬಟ್ ಐ ಡೋಂಟ್ ಫೀಲ್ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗತ್ತೋ ಇಲ್ಲೋ. ಬಟ್ ಕೇಳ್ಬೇಕು ಅವ್ರನ್ನ, ಅದ್ ಹೆಂಗೆ ಮೇ ಬಿ ಶಿ ಇಸ್ ಕೆಪ್ಟ್ ದ ಡುವೆಲ್ ಸಿಂಪ್ಲೆಕ್ಸ್ ಅಟ್ ದಿ ಎಂಡ್. ಮೇ ಬಿ ಸುಮ್ನೆ ಒಂದೇ ಸರ್ತಿ ಹೇಳಿದ್ರು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಲ್ಲ, ಬಿಟ್ಟಿರ್ಬೋದು ಅವ್ರದ್ನ ಲಾಸ್ಟ್ಗೆ ಹೇಳಿದ್ರ ಆಯ್ತು ಅಂತ. ಲೆಟ್ಸ್ ಸಿ, ನೋಡೋಣ. ಅವ್ರ ಹಂಗೇನಾದ್ರು ಬಿಟ್ರೆ ನೆಕ್ಸ್ಟ್ ವೀಕ್ ವಿ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದಿ ಟ್ರಾನ್ಸ್ಪೋರ್ಟೇಷನ್. ಈವನ್ ಐ ವಿಲ್ ಕಂಪ್ಲೀಟ್ ದಟ್ ಅಟ್ ದಿ ಎಂಡ್ ಓನ್ಲಿ, that one method. Otherwise I'll finish off that and start with the transportation.
Okay, ma'am.
Okay.
No problem.
I'm sad. Call mother, appa. Call mother, appa.
He might be hiding somewhere. Go.
Hogle, find her. Hogle, find her.
In 10 minutes. Okay, you go find her. Find him. Okay.
Can Hogle find Male?
No going downstairs. Monster item. Okay, in the first two, there is the difference, that is the modification in the objective function. That is, you need to consider here.
We should neglect the artificial variables,
Yes,
right?
yes. It's as simple as that. You need to neglect the artificial variables and consider the surplus variables.
Fine.
Okay, that is, considering surplus variable are nothing but your original coefficients here. 10, 6, 2, 0, 0. That's it. And here, okay, coming to this picture, that is in the basic variable and A1s, what you need to do here is you need to make use of this table. So as it is, whatever we have stopped, that is x2 and x1, and the same values of A11, A12, A13, A14, A15, same values, that is 0, 1, 1 by 2, minus 3 by 4, minus 1 by 4, 5 by 4. Same table or same is what we can see here. And 1, 0, minus 1 by 2, 1 by 4, minus 1 by 4, 1 by 4. Same, whatever the values you can see, you need to transfer here, but not the basic coefficients of x2 and x1 here. x1 is 10, x2 is 6. So can you see the difference here? What we have done here is, instead of all these zeros, we have understood that we need to go for the next phase. So for next phase, you need to make use of original coefficients by neglecting the artificial variables and using the same A11, A12, A13, A14, A15, 21, 22, 23, 24, 25, what values you can see here in the previous table as A's, and modifying the coefficient of x1 and x2. Then
No, but
again repeat this.
these are the iterated values of A1, A, no, ma'am. They are not the
Yes.
actual x1 values.
No.
Then
The hello.
But then we are taking the CJ values as our previous values, which were not used in the iteration process. So
ಈಗ ಮತ್ತೆ CJ values will change. Is it not? Here the CJ values, what CJ okay, ZJ values what you have got is with respect to these coefficients. But now here you need to consider the coefficients of the original objective function. Only you need to play with this z values. Before it was 0, x1, x2, x3, s1, s2. Only a1 and a2 were there. In this phase, we need to neglect a1 and a2, but we need to make use of the a's, what you can see. That is a11, small a11, a12, 13, 14, 15. As it is what we have stopped in the previous step. This is how we switch to phase 2 using the phase 1. Only modifying the objective function. Is that fine?
Yes, ma'am.
Okay. Now coming to the calculation part, zj. So 6 into 0, 10 into 1 is 10. 6 into 1, 10 into 0 is 6. Similarly, minus 2, minus 2, minus 4, and 10. Check this. Then Cj minus Zj. 10 minus 10 is 0. 6 minus 6 is 0. 2 minus of minus 2 is plus 2. 0 minus of minus 2 is
That is plus 4, ma'am.
4. 4. Yeah. 2 and 4. Okay. Now you can see Cj minus Zj are greater than or equal to 0. All the values. Can you see this?
Yes, ma'am.
Can you see? Okay.
Yes, ma'am.
So now you need to stop here and write x1, x2, x3 and z. So what is x1?
10, ma'am.
10.
Hey, x1 is basic variable object. Yeah, x1 is the basic variable. So what is x1? In the solution you need to see. Yesterday also I've mentioned, I'm repeating, most of the students go wrong taking
by-
these as the answer, but this is the answer. So 1 by 4, very good. X2 is?
5 by 4, ma'am.
Yes. X3 is?
0.
0. Z is? 10.
10, ma'am.
Okay. So you can just check or cross check by taking the Z equation. Z is 2x1 minus 3x2. Sorry. What is Z?
10x1
Z.
plus 6x2 plus 2x3, ma'am.
Yes. 10 plus 6x2, 2x3. You can substitute and see. 10 into 1 by 4 plus 6 into 5 by 4 plus 0. So are you getting 10 and 10 here?
Yes, ma'am.
Okay. So here you need to stop, and this is the optimal solution. That is x1 is 1 by 4, x2 is 5 by 4 and z is 0. X3 we have not yet, that x3 is not entered the table. So you need to just consider that as 0. Is it fine?
So for bigger method and the other methods, we use the solution for x1, x2, ma'am. Whereas the simplest method, we go for zz values for x1, x2 for the solution part.
ಇಲ್ಲ ಸರ್, ಎಲ್ಲದಕ್ಕೂ ಸೊಲ್ಯೂಷನ್ ನೋಡ್ಬೇಕು. Here also we have seen the solution only. ನೋಡಿ last class ಅಲ್ಲಿ. Okay, coming to x1, x2, x3,
ಇಲ್ಲ ma'am,
6 by
I'm
5, 6
talking
method
about
ಅಲ್ಲಿ-
simplex part, ma'am. In simplex
ಮೆಥಡ್
method,
ಅಲ್ಲಿ
we have taken zz values are x1 and x2, ma'am.
ಇಲ್ಲ ತಪ್ಪಂದ್ರ ಅದು ನೋಡಿ ಇದನ್ನ.
ನೀವೇ ಬರ್ಸಿದ್ದೀರಾ ಮ್ಯಾಮ್? CJ
ಹೌದಾ?
ವ್ಯಾಲ್ಯೂನೇ ಬರ್ಸಿದ್ದೀರಾ? ಹಾ ಮ್ಯಾಮ್. x1 x2 ಗೆ z ವ್ಯಾಲ್ಯೂ
ಹೌದಲ್ಲ
ಮಾತ್ರ 120 ತಗೊಂಡಿದ್ದೀರಾ.
No 2 and 8 here ಅಲ್ಲ ಇಲ್ಲೆಲ್ಲ.
ಹಾ ಮ್ಯಾಮ್.
ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. ಎಸ್ ಮ್ಯಾಮ್.
Yes sorry make a change there.
ಇದರ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ರಾಂಗ್ ಬರ್ದಿದೀನಿ ಮ್ಯಾಮ್.
ಹೋಗ್ಲಿ ಬಿಡು, ನಾನು ನೋಡ್ಕೋತೀನಿ ಅದ್ರಲ್ಲಿ. Okay, so this is two phase. ಏನಂತ ಹೇಳ್ತೀನಿ ಅಂದಿದ್ದೆ ಇವತ್ತು ಮತ್ತೆ. Okay, so last point here, that is, for example, one ನಿಮಿಷ. Okay, if z is 2x1 minus 3x2 plus 6x3 subjected to 3x1 minus x2 plus 2x3 less than or equal to 7, 2x1 plus 4x2 greater than or equal to minus 12, minus 4x1 plus 3x2 plus 8x3 less than or equal to 10. So in this case, okay, what do you need to do if it is a simplex method?
I was kidding.
Suni. So in this case, what you need to do here is, this is greater than or equal to, if it is for the simplex, what you need to do is, you need to multiply this constraint with minus 1. So 3x1 minus 3 minus x2 plus 2x3 less than or equal to 7, minus 2x1 minus 4x2 less than or equal to plus 12. Third constraint is as it is. Like this. Okay, so this we didn't discussed, right? While
This is for simplex method, ma'am.
yes, this is for the simplex method. And if it is for the big game or the other thing, then you can always, okay. One thing here, the good question. If for say for the big game method, this is okay, but this is not okay if it is minus. So if in the big game method also, if you are asked to solve this using the big game or any method, this right side what you can see cannot be minus sign. So if it is a minus sign, then you need to always multiply the entire constraint by minus 1. This you need to keep in mind. Or in the other way, if the symbol is like this and this is plus 12, then you can use the artificial and the surplus variables. Okay.
No, but they are having the surplus variable method even for simplex method, no? That so we can directly add, we can directly subtract s from the equation and write it equal to the whatever value is there right now.
Yes. Only thing is, whatever we write is, this is ax is equal to b form. Okay, so this b should not be negative.
Okay.
That should be always positive. That's it. Okay, and in the simplex method, we always use only the slack variables. This you need to keep in mind. that is plus S1 plus S2 hinge. There is no question of surplus or the artificial variable. Is that fine? So
Yes, ma'am.
if you are asked to solve the problem using the simplex, and if you have, say for example, this is greater than or equal to, then you need to convert that equation as the less than or equal to by multiplying -1 throughout the constraint equation. ಅರ್ಥ ಆಯ್ತಾ? Is that fine?
Ma'am, repeat it once,
ಮ್ಯಾಮ್ ಇದು ರೆಕಾರ್ಡ್ ಮಾಡ್ಕೊಂಡಿರಲ್ಲ ಮ್ಯಾಮ್, ಅದು ನಿಮ್ ಗೂಗಲ್ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಆಗ್ತದೆ, ನಮ್
ಅಲ್ಲಿ
ಇದ್ರಲ್ಲಿ
ನಿತೀಶ್
ಹಾಕಲ್ವಾ?
ಹತ್ರ ಇದೆ ಅದು,
At
ಹಾಕ್ಬಿಡು
YouTube
ನಿತೀಶ್
ಅಲ್ಲಿ ಇದೆ
ಬೇಕಂದ್ರೆ.
ma'am. It's all in YouTube.
ಕೊಟ್ಬಿಡು ಅವ್ರಿಗೆ, ಆಯ್ತಾ?
ಹಾ ma'am.
ಯಾರ್ಯಾರಿಗೆ ಬೇಕು. ಸಿ ವಾಟ್ ಐ ವಾಸ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಇಸ್, ಸಪೋಸ್ ಈಗ ಸೇಮ್ ಸೆಟ್ ಆಫ್ ಈಕ್ವೇಶನ್ಸ್ ನ ತಗೋತೀನಿ. plus 2x3 is less than or equal to 7, 2x1 plus 4x2 greater than or equal to -12, and 4x1 plus 3x2 plus 8x3 less than or equal to 10. Okay, so in this, if you see the symbols are less than or equal to, greater than or equal to, or less than or equal to. So what happens here is there are two things to be again considered. One is, if this is solved using the simplex method, then everything must be less than or equal to. Okay, so you are asked to solve this using the simplex, then you need to convert all the symbols in the less than or equal to. So to do that, what you do, for this particular equation you multiply by -1. This is one thing. Okay, and the same problem, if it is solved using the big M method, then also you need to multiply by -1. You may ask me that why we need to multiply by -1, as we can use the surplus and the artificial variables here for greater than or equal to symbol, but there is -12 here. So always remember this equation, what you can see, that is the constrained equation, are in the form of ax plus b. Ax is equal to b. This b cannot be the negative. Is that okay? So if it is for the big M method, then also you need to multiply by -1. If, say suppose it is 12, that is not a -12 but +12, then no need to multiply by -1 if it is a big M method. In that case, the two-phase method also, because you can easily use the artificial and surplus variable. Is that
Ma'am,
fine?
if it is +12 in simplest method, what should we do, ma'am? Greater than or equal to symbol and +12 is there.
Okay, in that case, you cannot solve that using the simplex method. You can just state that this cannot be solved using the simplex method. So using the next method, maybe the big M or the two-phase, we can solve this. You can go for any method which is easy and which is lesser time consumption. You can go for big M or two-phase, anything. Because what happens here is, if you want to convert this greater than or equal to the less than or equal to, this becomes again -12. Alva?
Yes, ma'am. Yes, ma'am.
So that is again wrong thing. So you can just state that this cannot be solved using the simplex one. Is that okay?
Yes, ma'am. Got it.
Okay, so these were some key points or key tips which I wanted to clear. And there is one method left in this group, that is the dual simplex, that we will discuss in the coming class, that is next week class. In between, if possible, I'll take one class and finish up that dual simplex. And there is something small topic called as duality. Okay, that also we will discuss in the coming week only. Is that fine? So today I think it's enough. You can practice all these problems, please. Okay. And this you can take it as the simplex method minimization problem. Practice this also. Is that okay?
Yes, ma'am.
Any doubts? ಏನಾದರೂ ಇದ್ರೆ ಕೇಳಿ. ಇಲ್ಲ ಅಂದ್ರೆ we will stop here. If you solve them, if you understand each and every point, then all the methods are easy. If you don't practice them, then it will be again a problem. So practice them, please. Okay. I'm not asking you to practice some 5 or 6 in each. 2 one minimization, one maximization, one minimization, one maximization, so that you will be having that comfort zone. Okay. Fine then. Can we wind up?
Yes, ma'am.
Okay, thank you.